And throughout it's going to be 1 hour long, and throughout the workshop, feel free to ask questions to us either like by unmuting, or you can ask in the chat too. Okay, so I guess we just wanted to jump in and go over some intro Python. So the first thing we're going to talk about today is print statements. So if you guys all want to go to the website repl.it, it should open for you a place where you can run Python. Yeah, I think she just sent it in the chat, but yeah, so if you go to that website, and then you should be able to create a new Python program, and let us know if you guys have that running, or if you have any questions you can ask in chat too. And that's how we're going to be running our Python today. So I guess I can go to it too. But you should be led to this page where you can just click Start Coding, and you can sign up. But I think there's a way where you don't have to sign up too. But if you want to log in or make an account, you can do that, and then you should be able to make a new Python program. So maybe let us know in the chat if you guys have a REPL working, or if you have any questions on how to open it. Okay, cool. So just to start, we were going to start by talking about print statements. So print statements are an easy thing you can do in Python to just print something out on the console of Python. And it's a helpful way to debug your code, or to print outputs. Like if you're trying to do calculations, you can print things out. And so whenever we print stuff, you can type it, you just type print parentheses, and then whatever's on the inside of the parentheses is what you're going to print. So in this case, you guys can maybe just try typing print hello world, and if you hit the run button, you should see hello world gets printed in the console. And right here you can see we put the hello world in quotes, because here we're trying to print a string, which is pretty much a way to let Python know that this is a block of text that you want to print. So if you were going to print numbers or some other variable type, you wouldn't want to put it in quotes.
Okay, so variables are basically ways to store data values in Python. So unlike variables in math, as it says on the screen, variables don't have to be just numbers. In the example before, we saw a string called hello world. So you can technically have variables that are strings. You can have them be floats. You can have them be integers. You can have them be anything you want. Here on the bottom of the screen, we have two examples. So the variable x is set to Python is cool. And remember that when it's a string, you want to put it in quotation marks. So here you see that we put Python is cool in quotation marks um, as being stored in x. Y stores the number 3, and when you just have a number with no decimal points or anything, that's called an integer. You can also store decimal numbers, which, as I said before, are called floats. So if you want, you can say like z is equal to 4.5 or something like that. And that's basically how you store a variable. They can be of any type. Just make sure that you have the correct syntax for it. But don't worry about adding this to your code just yet.
Yeah, so like we kind of talked about earlier, strings are a data type in Python, and they're indicated by you can either use double quotes or single quotes around the text that you want to make a string. So for example, this is an example of a string, you just put quotes around it. And in Python, you can do this thing called string concatenation too, which is just a fancy way of saying like putting two strings together. And you can just do this with a plus operator, just like you would do with adding numbers. So for example, you guys can try typing print hello in quotes plus world in quotes and see what that outputs. So this is an example of string concatenation where it should just put these two together when it outputs the print statement.
Um, so we would like to give you guys an opportunity to try testing this out as well. So what you guys can do is save a string 1 in the variable first. And you guys can technically store integers as strings if you put quotation marks around it. So in this case, 1 is being saved as a string. So we want you guys to save 1 and 2 in the variables first and second, and then try concatenating them and see what you end up outputting in your code.
Yeah, and maybe you can type in chat what you get as the output. Yeah, so it seems like a lot of people are getting 12, which is what we would expect if we're just putting, you can just imagine it being putting these two strings right next to each other. So now instead of adding those two strings together, if you guys try just printing 1 plus 2, where the 1 and 2 aren't inside of quotes, and then you can send to the chat what you get from this. And yeah, a lot of people are getting 3 because now instead of just putting two strings next to each other, these numbers are being stored as integers. So when we add them using the plus, it just does the math and prints out 3. Okay, cool.
Great. Let's try another example. This time we would like you guys to print 4 times 4 and then 5 with 2 multiplication signs and then 2. Let us know what you get in the chat. Yep, a lot of people are saying 16 and 25. That's correct. So basically what the 1 multiplication sign does is it just multiplies the two numbers together. But when you have two asterisks, it actually raises the first number to the power of the second number. So the reason you got 25 is because it did 5 squared for the second statement.
Okay, so now we're gonna have you guys try printing this, where we're printing a string which says the answer is, and we're adding it to an integer value of 5 times 5. And let us know what you get when you run this. And yes, if you print 5 star star, oh yeah, okay. Yeah, so in this case, we are actually expecting you to get an error, and you guys could probably guess the reason why it's erroring is because we're only allowed to add strings to other strings. And in this case, you're adding a string to this like numerical value, so that's what it's erroring at. Um, yeah, so this kind of just says what I just said, how integers should be converted to string if you wanted to concatenate it with another string. And also something useful about Replit is that it should color code your variables based on their data type. So you can see here that the string is in red, whereas the numbers are in green, or the integers in green.
Awesome. Okay, so this time we want you guys to try printing this, where we have the same sort of format as before. We have a string, the answer is, but here we see that we're casting 5 times 5 as a string, which basically means we're converting an integer to a string. So try this out and let us know how it works. Yep, the answer is 25 is correct, and that's what you should have gotten this one. And the reason that it worked this time, as I said before, is because here we actually converted it to a string, so now they're the same data type. Now we'd like you guys to try coding a problem yourself where you where the code will display the circumference and an area of a circle with a radius 5. So remember we showed you guys how to square a number, how to multiply numbers, and then how to print numbers. So print numbers and strings together. So let us know if you guys are able to figure it out, and then we can show you the answer. We'll give you about 2 to 3 minutes to work on. Let us know in the chat when you think you've got it and also what your answers are. Good. I think we're getting a few answers in the chat, and they all look pretty good to me. Um, but on the screen, we have the final answer. And there can be slight variations, if you change the variable name, etc. But here's just an example of what we did to solve this problem.
Okay, cool. So now we wanted to talk a little bit about parameters.
Wait, I think we
So,
might have skipped a slide.
oh, oops. Okay, yeah, sorry. We'll start by talking about functions. So in Python, functions are an easy way to program something that takes an input and produces an output that you can then reuse multiple times. So instead of just like copying and pasting a block of code, you can build a function to do something that you can repeatedly call that function for. So it can help make your code more efficient. This is just the basic syntax of how to define a function. So you can type def, and then here is your function name. So in this case, we're just calling it my function. You can call it anything you want. And then you put these parentheses. And if you had a function that was taking in an input, this would be where you would specify your input variables. But for now, we're just going to leave that blank because we're just going to make a function that takes no inputs. After the parentheses, you put a colon, and then in the next line is where you start writing what your function does. And you want to make sure that everything here that is like the part where you're telling your function what to do is indented inside this def line. Because in Python, the syntax is very specific about indenting, and you can get errors if you don't indent things. So on the inside, we just want to write print hello from a function, or you can print anything you want. And these first two lines are how you define the function. And now if I want to run the function, I can just type my function parentheses, and this should run your function. So in this case, this should print hello from a function. And yeah, you guys can try this if you want, but you don't have to worry about copying everything down too.
Okay, so when you make a function, you can also include parameters, which are basically inputs. So let's say that you want to print your first name and the last name, but the first name and the last name is going to depend on the person who's actually using it. Then you can add these two parameters here, fname and last name, and lname, which you put inside the parentheses after my function. Then when you're actually making the method, you can say print, and then you can call the parameters and say fname plus space plus last name. And that'll basically return print and then fname space last name. And then if you actually want to use the function, when you call the function in the parentheses, instead of saying fname, lname, you put the actual values that you want those to be. So let's say, my first name is Meha and my last name is Goyal. Then inside the my function parentheses, when I call the function, I can say my function Meha, comma, Goyal, close parentheses. And then when it runs the function, it'll print Meha plus space plus Goyal. And that way you guys can start putting inputs in, and you can have different outputs based on the parameters that you put in.
Okay, cool. And another thing that's often useful that you can do in Python is you can create these things called if-else loops or if-else statements. And these are like conditional statements which can help you start to build things that depend on certain things to run. So in this case, we just set two variables, a equals 33, b equals 200. And we're making this really simple conditional statement where we say if b is greater than a, then you print b is greater than a in strings, or in quotes as a string. So for if-else statements, they're pretty simple. You can just write if, and then in this place, you can really put any conditional statement you want. So you can say if b equals a, if b is less than a, and then it will only do what's inside of this indent if this is true. So in this case, do you think it would print b is greater than a? Maybe you can type it in the chat. Yeah, so it would because here in the statement B is greater than A.
Okay, so while loops are slightly more complicated because we have a few different functions we can do with it. So first, let's look at the first example. While I is less than 6, print I, and then I plus equals 1. So here we define I as 1 at the really top. So when we say while I is less than 6, we look at the variable at the moment. So I is 1. So since 1 is less than 6, it'll print I, so it'll print 1. And then it'll go to the next statement, which is I plus equals 1. So now you have 2. And it'll go back to the loop and say 2 is less than 6. And then it'll print 2. And then it'll add 1. And then you get 3 is less than 6. So that's basically what a while loop does. So long as the condition in the statement is true, it'll perform all of the methods below it. But one thing to remember is that when you use a while loop, you have to make sure that you have a method that brings you closer and closer to the condition. Because let's say this was actually I minus equals 1, right? Then if you start at I equals 1 and you say while I is less than 6, subtract 1 from it, then it's always going to be less than 6 and you'll get stuck in an infinite loop where your computer is basically going to crash. So you want to make sure that whenever you have a while loop, within the while loop, you have some condition that's bringing it closer and closer to the statement that you're making. If you look at the second column, we have another condition within the while loop, which is if I is equal to 3, break. And what break basically means is you want to like stop. Like you don't want to, if I is equal to 3, you no longer complete the rest of the loop. You just go back to the beginning, if that makes sense. So like if you type in break, it just doesn't finish the rest of the while loop. On the other hand, if you have continue, it'll restart from the beginning. So the way this works, is there a question? Oh, yeah. So the difference between break and continue is that if you say break, it's just not going to keep going in the loop. Whereas if you say continue, it's not going to do the next statement. It's just going to restart the loop from where it's at. And then finally, you can have an else statement where it's like, while I is less than 6, do these two things. But then once I is no longer less than 6, you want to print something. You technically don't always need the else statement because once you're no longer in the while loop and you like unindent it, the next method will only occur after the while loop is false. But here the else just makes it clear that if I is no longer less than 6, then print I is no longer less than 6.
Yeah, and so in that case, we were talking about while loops. There's another type of loop called for loops, which act kind of similarly. It's another way to go about like repeating a certain function or a certain block of code. So instead of like in while loops where you give a condition, in for loops, you're often iterating over a list or a like a list of numbers, if that makes sense. So in this first example at the top, we start by defining a list called fruits. And in Python, the way you define lists is you use these square brackets. So here we have a list of 3 strings, apple, banana, and cherry. And then if we want to use a for loop to loop through this list, we can say for x in fruits. So in this line, x can be any variable name you want. It's just the variable you're using to iterate. And we're saying fruits, which is the name of the list, colon, and then indented here, we say print x. So for this for loop, what it will do, it will say for each item in fruits, we're going to do this to it. So first it'll print apple, then it'll print banana, then it'll print cherry. Another example of a for loop is you can say for, or we can look at this example here. You can say for x in range. And what the range function does in Python is it just makes a list of numbers from 0. If you just put one number in here, it'll make a list from 0 to 6. So in this case, when you say print x, it'll print 0, 1, 2, 3, dot, 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 etc. And here you can see like there's other different inputs of range you can give, which change like the list of numbers that you're iterating through, but it's kind of the same main idea where you're looping through a certain variable in this list of numbers or this list of strings in this case. Okay. Are there any questions overall at this point about any of the Python stuff we talked about?
What happens when you put three numbers in the for loop?
Which loop are you? Oh, wait, can you go to the slide? Oh, are you talking about this one here at the bottom? 233.
Yeah.
Okay, so basically what happens there is that it starts at 2 and it goes all the way to 30, but now it does it in increments of 3. So instead of doing like 2, 3, 4, 5, it'll go from 2 to 5 to 8 to 11, like that. Does that
Oh,
make
okay,
sense?
thanks.
Okay, so now we're going to move on to the machine learning part, and this will be a lot more like high level idea stuff. We won't be doing as much programming, but the reason that we combined Python with machine learning is that Python's a really useful tool for working with data, and that's a big part of machine learning. So a lot of machine learning is often done with Python using like the for loops and lists that we were talking about earlier. So to start off, what is machine learning? Um, it's defined as the subfield of computer science that gives computers the ability to learn without being explicitly programmed. So pretty much machine learning is a collection of techniques and algorithms that can let the computer learn from examples. So the idea is that instead of having humans come up with the rules, which is what we were doing earlier by like making the if-else statements and making the for loops, we instead let the computer kind of figure out the algorithms and the relationships in the data on its own without like pre-programmed explicit instructions. So here on the right, this is an XKCD comic that's kind of about machine learning. So you can see how it's really a lot less organized in a way, and it's more about letting the computer learn on its own from data. Okay, so why machine learning? Machine learning is like a pretty big research area right now, and it's really exciting. And that's because machine learning allows us to easily develop systems that can automatically adapt and customize themselves to individual users. So, for example, like your email spam filters or like personalized news or anything personalized really often is from machine learning or AI. Um, Machine learning also has the ability to mimic humans and replace certain monotonous tasks, but tasks that still require some effort. So, like recognizing handwritten characters or like recognizing things in an image, face detection, things like that. And machine learning can also help us discover new knowledge from large databases, which might be hard to do using other types of programming. And then for why machine learning is so popular now, a big reason is that there's this flood of available data. So, with all of our phones and the internet, there's a lot of available data to use for machine learning, and data is a really important part of it. Also, there's increasing computational power, which is important to like develop good models in machine learning. And yeah, it's like a really big research area right now. So there's growing progress in available algorithms and theories developed by researchers. And there's also increasing support from different industries. So you'll see that machine learning is also pretty interdisciplinary now and used in a wide range of industries. Yeah. So some examples of the different applications of machine learning. You can see in this chart, there's a lot of different applications that can pretty much be applied anywhere. Some of the examples here are like in social media, self-driving cars are an example of machine learning. There's a lot of areas that of areas that machine learning can be used in healthcare and like in discovering drugs or diagnosing diseases. Um, and yeah, virtual assistants or like chatbots are all machine learning run too. And some really interesting research areas that are really popular now. One of them is computer vision, which you guys might be familiar with. So, like, self driving cars is an example of using computer vision, or like classifying images or face detection. Um, Natural language processing is also a really interesting area of machine learning, and this deals with text. So, if you ever see like those automated chatbots or like Amazon Alexa or Echo or all of that, those all use natural language processing to kind of mimic speech and analyze language using machine learning. Um, there's also a lot of applications in robotics and biology, which was kind of like the healthcare stuff I mentioned earlier. And finally, there's this really interesting area of machine learning that's called generative ML, where machine learning models are actually learning how to make art and music based on other art, which is really cool. So these are some like really exciting areas that are becoming, yeah, popular and yeah, right now. So in terms of how the machine learning process works, like I mentioned earlier, a big part of machine learning is data. So really the computer is learning from examples, it's learning from finding patterns in data. So data gathering and data pre-processing are probably some of the most important steps to this. So yeah, the process starts by researchers will input data sets and process the data sets. And another data processing technique they do is feature engineering. So in a data set, features are kind of like what you can think of as the columns or like different characteristics of the data set. So if I had data on like um, an animal, for example, and like I would have different features like whether that animal has ears or not, whether that animal has fur, and those are all different features of your data set. And then after you kind of choose what part of the data you want to keep, which is what feature engineering is, you then go into the algorithm selection and training. And this is kind of like the part that people think of as a black box because you pretty much feed the data into this algorithm that you can decide, but from then on, the machine learning model is kind of learning on its own. And this is where it like does the self-learning and mimicking human learning part that I was talking about. And finally, once you have this model that has learned, then you can use it to make predictions. And yeah, you can also evaluate the model to see how accurate it is. And this is kind of the cool part where you can like then apply it to different problems. And yeah. So again, just want to emphasize that machine learning really relies on data and examples in order to learn. But within machine learning, there's a few different types of tasks and types of learning that computers can do. So in terms of types of tasks, I'll talk about these a little bit later, but some examples are like classification, clustering, regression, translation, anomaly detection, and generation. And then there's two main types of learning when we think about machine learning. The first type is supervised learning. So this is the type where I, as like a computer scientist, would input lots of data and lots of like answers to the data into the model. So for example, I would input a bunch of pictures of dogs and I would tell the model that, oh, those are pictures of dogs. I would also input a bunch of pictures of cats and tell the model that, oh, these are cats. And then I feed that into the computer, and the computer then learns from these examples. So when I give it a random image of a cat or a dog in the future, it can then look back and see what it's learned and then say, oh, that's a cat or that's a dog. So that's what supervised learning is. But there's also a type of learning called unsupervised learning, where instead of feeding in the data and giving it the answer, so instead of feeding it pictures of dogs and telling the computer that these are dogs, I would just feed it in a bunch of images of cats and dogs, but I wouldn't say which ones are cats and dogs. And instead, the machine learning model would kind of look through the data on its own and find like differences and try to like categorize the images without necessarily like the labels or the solutions. So yeah, the first type of problem that I was talking about earlier is classification. And this is pretty much asking the question of like, what group or category does each data point belong to? And typically there are a finite number of groups or labels that are known ahead of time. So for example, what I was just saying just now with like categorization of images into cats or dogs, that's an example of classification because we're trying to classify the images into two categories. And some other examples of classification are it's often used in computer vision, like when we're trying to recognize certain things in images. And also the example of email spam filters is another example of classification because we're classifying emails into spam or not spam. And you might be wondering like what exactly the model that does classification would be doing. So there's a bunch of different models that do classification, but one example that I'll show today is called decision trees. So these are models that pretty much they take in the data and what they're learning in the data is how to build like a tree that kind of makes the decisions. So in this case, this is an example of a tree. So if I inputted data on like where some of the features were like whether I'm hungry or not, or what the weather's like, and I want the model to classify whether I should take the bus or walk. This might be like a tree that the computer comes up with to determine how to categorize the different walk or bus decisions based on the different features, like how much time I have, how hungry I am, or what the weather's like. Um, Other than classification, another type of problem that you can do is regression. And instead of classification, where you're like categorizing data into different categories, regression is more of a like continuous data. So it can predict a numerical value for a given data point, given other information about the data point. So another way to think about it is that it learns the parameters of an equation that gives the relationship or the line of best fit between certain variables in the data. So the most simple regression you can think about is linear regression, which is what this graph is showing. So if I had like data about maybe the price of a house versus like maybe, I don't know, the size of a house or yeah. I could then plot these data points like this and determine a line of best fit. And this could then let me make predictions. So if I have a house that is like this size, for example, I could then predict the price of it based on this curve that I fit. And in this case, we're just using two variables, but regression can also become like include a lot more variables and become more multidimensional, which makes it a lot more like complicated and predictive. And then finally, another type of learning is called clustering. So instead of classification, well, it's a type of classification, but instead of regression where you're trying to like determine a numerical output, in clustering, what we do is you kind of just plot all the data points together and try to figure out which data points are related to one another. So in this case, you can see that here the data points are plotted like this, and what we would want the model to learn is like where these lines are drawn and how to like cluster the data to itself, if that makes sense, into these smaller groups. So examples of where clustering would be used are in like market research or pattern recognition, or also image processing. So now we wanted to let you guys try it yourself, kind of. So I'll send this link into the chat. Oh yeah, okay, cool. And what this will bring you to is this website, and it's a little complicated at first, but pretty much what this is doing is you can start by choosing which data set you want to use. It's really up to you for this. And this is like what your goal or your problem you're trying to solve is. So what you're trying to do here is you're trying to make a model that will classify between orange points and blue points. So let's say I just choose this one. And then you remember I was talking about features. So features are like the different data properties that I want to feed into the model. So here right now it's just using 2, but I can like add more or you can subtract more. It's really up to you. And then this part you don't have to worry as much about. This is simulating a neural network model, which are pretty complicated, but you can just think of them as like a machine learning model that's trying to learn. So you can play around here with like adding different layers or adding like the neurons. You don't really have to worry much about like what the math behind all of this is. And then when you're ready to start training it, you can click this run button and you can see what happens here. So in this case, I think the model is doing a pretty good job in like, you can see it kind of creates a divide between the two data points. But yeah, you can see how like changing the amount of layers or like the amount of input data. So like if I uncheck a bunch of these, you can see how that might change how the model gets trained. So yeah, we'll give you maybe like 5 minutes to play around with this. And if you have any questions, you can ask them too, because I know it went pretty quickly through all the stuff earlier. And yeah, so this last spiral data set might be a bit harder to do, so you guys can try to see if you can figure out a way to make a model that predicts it pretty well. So you can see mine isn't doing that great in predicting the orange and blue. Okay, I think we might move on, but did anyone come up with a good way to classify the spiral or any of these data sets? Another thing that's kind of cool that I forgot to mention is that in these little squares, you can kind of see like hints of what the machine learning model is kind of looking for in your data to predict this data. Okay. So one last thing we wanted to talk about in regards to machine learning is that there's a lot of different ethical issues that should be kept in mind, and you guys might have heard about some of these, but they mainly fall under these categories. The first one is privacy. So with machine learning and AI, a lot of it relies on data, which is what I talked about earlier. So I guess this can lead to some privacy issues of like if people don't want this type of data collected about them. And yeah, kind of like the side effects of having all this data accessible and being collected on everyone. Another thing is bias. So since the machine learning models are learning from examples, if the examples and the data that we're feeding in is biased, then the machine learning models are going to be biased. So this is definitely a big problem and something that should be kept in mind when people are designing these complicated algorithms. Something that another category is kind of abuse and misuse. So how to make sure that people don't abuse um, machine learning models and kind of, yeah, like how powerful the technology is at this point. Um, Another interesting thing is model explainability. So like I was talking about earlier, people sometimes call like machine learning models black boxes because we really don't know what we don't always know like what the machine learning model is learning. Often it's just like you feed in data and then the machine learning model does its own thing and then it makes predictions. So something interesting to think about is like does it matter how explainable a model is as long as it makes good predictions? So, like, if there was a machine learning model that was like diagnosing patients for cancer, and its accuracy was really high, so it did do a good job, but we didn't know what the model was looking for in order to diagnose for cancer. So you really don't know like what the model is doing. Would you still trust it? I guess that's an interesting question to think about and like how important it is to be able to explain what the machine is doing. Another ethical issue is responsibility. So like if a machine learning model makes a mistake or like if a self-driving car makes a mistake, for example, who's responsible? And this gets a lot more complicated when it's like the computer that's making the decision and it's not an actual human. So would it be the person who like made the self-driving car is responsible or the person who decided to use the self-driving car is responsible? It's kind of unclear. Um, Something that people are talking about too is automation of labor. So like does machine learning models and like computers becoming more intelligent put people out of jobs because they're now being replaced by computers? Or does it open new jobs and like thinking about that? And finally, I guess the kind of sci-fi one is existential risks. So I guess would it be possible to make a computer that's smart enough that it would like take over the world and like become smarter than humans is another thing. And I guess all of these ethical issues, they shouldn't really be seen as that discouraging because I think that AI and machine learning definitely have are super powerful and can like impact our world in a lot of good ways. It's just that these should be kept in mind when people are designing these models and we should always like design them with the ethics and morals to make sure that none of these things really become an issue. And yeah, so that's all we have for today. Um, You can there's a few more winter workshops, I think, for Code Innovate, so you guys should look into those to sign up for them. We hope you learned stuff today about Python or machine learning, and yeah, you can always email us if you have any more questions. And yeah, thank you for coming.
Thank you. Thank you.
Thank you.